All right, so I want to do this a little bit different and in hopes of basically distributing this information so that it's not so overwhelming. So I've got this lecture broken down in a couple of different pieces, so hopefully you can follow along bit by bit. So this first part is something that we actually talked about on the Thursday before spring break, and that is this idea of Kw. So Kw is what's also known as the auto-ionization constant of water. And Kw has a value, and that's a very important value for you to know, and that is 1 times 10 to the negative 14th, or 1.0 times 10 to the negative 14th at 25 degrees Celsius. And this is something that's going to come up in your homework problems. And what's valuable for you to know is that in your homework problems for chapter number 16, they're all done at 25 degrees Celsius. Now, to calculate Kw, you can effectively look at this as the concentration of your hydronium ions times the concentration of your hydroxide ions. That is going to be equal to 1.0 times 10 to the negative 14th. So one thing that's worth noting is about this Kw doesn't have any units. Now, we know that these two, molarity will be the units that we use there, but Kw does not have any units. Now, if we look at an example problem like this, calculate the concentration of hydroxide ions in a solution in which the hydrogen, or the protons, is 2 times 10 to the negative 6th. That's the same as your hydronium ions. You can set this up as Kw equals H plus times OH minus. Now you are not subtracting or adding these, instead you are multiplying them. Now we know that we can plug in 1.0 times 10 to the negative 14th. That is equal to my hydrogen ion concentration, 2.0 or 2 times 10 to the negative 6th, multiplied by the concentration of my hydroxide ions. Now I don't yet know my hydroxide ion concentration, and that's actually what my question is asking for. So what I'm going to do is simply do the algebra to get that hydroxide ion concentration by itself. So I'll divide each side by 2 times 10 to the negative 6th, and that's going to be OH minus is equal to 1.0 times 10 to the negative 14th divided by 2 to the negative 6th. I'm going to pause and then come back with the answer. And what I'm going to get for this is approximately 5 times 10 to the negative 9th molarity. So that's pretty much all there is to that sort of problem. And that's it.